or the bonus question for this, we are just going to get started with notes. We're going to be looking at what happens when we compare amounts of potential and kinetic energy at different points. We're going to start with potential energy, and when the height of an object increases, the potential energy also increases, or they both get bigger. Now we're going to look at the picture here. We're going to start at 1. So between 1 to 2, the height is increasing because 2 is higher up than 1. That means that 2 has more potential energy than 1. Now when we look at 2 to 3, the height again increases, which means that 3 has more potential energy than 2 because it's taller. Now between 3 and 4, again, the ball gets even taller, so the height increases. And so 4 is going to have more potential energy than 3. Now, we're going to look at what happens if the opposite occurs. So if the height of an object decreases or gets smaller, then the potential energy decreases too. Sorry if you guys can hear that craziness right now. My 2 cats, Rosie and Kiwi, are like wrestling and playing chase because they have a lot of energy right now. Anyways, we're going to look at what happens if we drop a ball and the height's going to get lower and lower and lower. So between A and B, the height decreases because the ball gets lower or closer to the ground, which means B is going to have less potential energy than A. Now between B and C, the ball gets even lower. So the height again decreases, which means that C is going to have less potential energy than B because it's lower than B. Between C and D, same thing. The height decreases again, which means our lower point D has less potential energy than C. And between D and E, the height gets even lower. So it decreases, and our E position is going to have even less potential energy than D. And between our last 2 positions of the ball, E and F, the height again is going to decrease, and I'm sure you guys already know what's coming. F is going to have less potential energy than E. So we just finished potential energy. Now we're going to look at kinetic energy. So when the speed of an object increases or gets faster, the kinetic energy is also going to increase. This happens because gravity is pulling down on objects, and it causes them to speed up the closer they get to the ground. So the fastest point something's going to be moving is at the bottom of a hill. Or think about when you're going down a slide, all right? You're going to be going fastest right here before you hit the ground. And as you go down, you're just going to be getting faster and faster and faster. And when we look at this picture right here, we are dropping a ball. So we start at A, and it has a speed of 0 meters per second. By the time it gets to F, it has a speed of 10 meters per second. That means that the speed of the ball is increasing. Therefore, its kinetic energy is increasing too. And now let's look at the opposite. When the speed of an object decreases, or it slows down, its kinetic energy is going to decrease or get smaller too. So once the ball hits the ground from above, you see it has a speed of 10 meters per second. So it's moving super fast. But as it bounces all the way back up, the speed drops to 4 meters per second. So the speed is getting slower or decreasing between 1 and 4. Therefore, its kinetic energy is going to decrease between 1 and 4 too. And now we have our last thing of notes, people, and then you'll be done. So we're going to look at when you drop a ball from point A to point F, okay? And so you're looking at what happens to the speed as it gets faster. So between A and B, the speed goes from 0 to 2 meters per second. So the speed increases, which means that B is going faster, so it's going to have more kinetic energy than A. Between B and C, we go from 2 to 4 for our speed, so it increases, which means C is faster, so it has more kinetic energy than B. The same thing happens between C and D. It gets even faster because our speed is increasing. And since D is moving faster, it has more kinetic energy than C. And it's getting close to the bottom. D and E, we go from 6 to 8 meters per second. It's getting even faster. It's increasing. And so E is going to have even more kinetic energy than D. And between our last two positions, E and F, the speed increases. We reach our final speed of 10 meters per second. So F has more kinetic energy than E. And guess what, guys? This assignment was 1 page right here. So once we do this, you're going to be done, okay? If you need to pause the notes back up here for anything, because I went fast, that is totally fine. Okay, so right here, we are going to be looking at I'll be talking you through a video that you're not going to watch, and you're going to look at how height and speed changes as the sky goes on the skate park. So this right here, this is the height. So we're going to go through and we're going to put the height for each of these positions. So at position A, he's at 4.5 meters, and I know that because here's 4, here's A, and it's halfway between 4 and 5. B, he's going to be at 2.5. C, he's at the bottom, so he's at 0 meters. D is up at 2 meters. E is 1 meter. F, we're going to say that's 3 meters. And G is going to be 4.5 meters. Now what we're going to do is I'm going to tell you what the speed was. So if we were to press play and you'd watch this person go, let me erase. You'd watch our little skater person go zoom, 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 then go back. I'm going to tell you what their speeds are at each of these positions. So at point A, our skater dude is moving at 0 meters per second. At point 2, or B, she's going to be moving at 4 meters per second. C, she's going to be going her fastest. She's at 10 meters per second. When she goes up to D, she's going to be at 6 meters per second. At E, she's going to be at 8 meters per second. And then when she goes up to F, she's going to be at 4 meters per second. And by the time she gets all the way back to G, she's going to be at 0 meters per second. So we can see here that the closer to the ground she gets, the faster she's going. And the higher up she goes, the slower she's going. So now we're going to answer our questions. So if we look here, position C, is it higher or lower than position A? It's lower, which means position C is going to have less potential energy than position A, because potential energy decreases the closer you get to the ground. C is closer to the ground, so it's going to have less potential energy. When we look at 3 and 4, we need to find position B to see if it has a faster, slower speed than position A. So let's go up here and look at B and A. So at A, it's at the very top. And the higher up something is, the slower it moves. So I know that B is going to have a faster speed because our skater girl is starting to go down the slide. And then that means that position B is going to have more kinetic energy because the faster you're going, the more kinetic energy you have.